Hello friends, this problem is called rabbits in forest. So let's see the problem. It says that there is a forest and there are unknown number of rabbits. We asked n rabbits. So there are more than n rabbits in the forest, but we ask n of them. Like how many rabbits have the same color as you? And we record their answers in a array, and this size is nothing but n. So each value corresponds to an answer from one of the rabbits. So in this case, we asked three rabbits. So clearly there are three rabbits. So they answer like correctly. How many other rabbits are of the same color as the rabbit themselves? So if a rabbit is of green color, and let's say there are total three green colored rabbits in the forest, and we ask this one, it will say that there are two more. So we record here. So for this case, first rabbit said one, second also said one, and third said two. So what is the minimum possible number of rabbits? We don't know the exact number of rabbits or the maximum number of rabbits. There may be a million rabbits and we just asked 10 of them. So we may never know how many total rabbits were there. But with the given combination of answers, what is the minimum possible number of rabbits? That is, below that, this answer would be invalid. So let's see a few examples, then it will be clear. So first example is that we asked three rabbits. Let's say we picked, there are many more rabbits, but we don't know them. So there are many more. Let's say we asked this rabbit, which is of red color. And it says that, yeah, there is one more rabbit of red color. Then we asked, let's say this one. This also says that, yeah, there is one more rabbit of this color, whichever I am. And then we asked one of these, let's say this one. Then it said that there are two more green rabbits. So we'll keep here. We did not ask this one, did not ask this one, and many more rabbits. So if some rabbit says that there is one more rabbit of this color, that means there are two rabbits of that color. And maybe that this one was something else. We don't know. Maybe this was green and this was blue. This is possible, but that will give more number of rabbits. So our goal is to minimize the number of rabbits. It may be possible that we asked a green rabbit and it said this is green, and then let's say there are two blue also, there are two yellow also, there may be many more. We asked one of the blue, this will also say one, and we might have recorded this one, but in with this approach we will have two rabbits, two more, and then here clearly three, because one the rabbit itself and two more, so we will get seven, but we can do with five only, as in this combination which we have here. So let's say first two are of the same color, and then next one clearly one other color, because it can be maximum two only, because there is one rabbit and one more. So this will definitely not belong to the previous color. So in this case, you can see that with five we can do that. We will arrive at a formal algorithm of how we will do that. But let's see a few cases. Like if a rabbit says that, if a rabbit gives answer of zero, that means this rabbit is of unique color. So whatever is color, this one, let's say C1. So this is unique. Let's say one more rabbit said zero. So clearly this is different color than any other rabbit, because that rabbit itself is the only rabbit, because there are zero other rabbits. Then C3, let's say some other rabbit also said. So whenever you encounter zero here in this list, input list, wherever we have zero, you can increment the count by one. Because, that is the only rabbit. So one rabbit. They are all unique rabbits. So we will account for zeros. Then if we have somebody gives answer one, then this rabbit and there is one more rabbit. And to minimize, we will, whenever we encounter any one, we will assume that it's the other one. So how many ones can belong to the same color in the answer? Two. If we have three rabbits answering one, 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 then clearly these are not all belonging to the same color. Maximum case would be that these all three are of three distinct colors. But to minimize, we will assume that we can pick any two, because maybe this rabbit is blue, this is also blue. So this is referring to other one and this is referring to other one. But beyond two, we cannot. Similarly, if we have some rabbit answers two, 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 let's see first three rabbits answer two. So maybe there are three blue rabbits. And we ask this one, this will say that two. When we ask this one, this will say two. When we ask this one, it will say two. So up to three twos are allowed and we can merge them in together. And the answer, we can count them as three. Yes, three rabbits will satisfy this condition. So now let's say we have this 1, 1, 2, our original example. So how many ones we can merge? Two. And result, we will add two. And if there is a two, minimum this rabbit and two more rabbits are there. So three. If the question was 1, 1, so in this case it's 5. But if the question was 1, 1, 2, 2, then also the answer would have been 5, because these two can belong to the same color. If the question was 1, 1, 2, 2, 2, still the answer would be 5. But if we have 1, 1, 2, 2, 2, 2, these two are of the same color, these three are of the same color, and this is some third color. And it says that there are two more, so 3. So in this case, the answer would be 5 plus 3, 8. So till this point, answer was 5, starting from 1, 1, 2. But as you add one more 2, it becomes 8. Now let's see one more example. So if we have 2, 2, 2, clearly maybe first time we asked this one and it says that two more. Second time we asked this one, two more. So in this case, answer is 3. So whatever is the value plus 1 for the rabbit himself or herself. And we can, if it crosses 3, we will add another 3. So in the multiples of 3. So if we have, let's say, a few unique values, let's say one more example. So clearly, as we had seen, this is not possible with 3 rabbits. We will have to take 6. We may pick any 4 you pick, they will say 2. This green will say that 2 more greens. Maybe then we pick this one, it will say 2 more reds. Third time we pick this one, it says 2 more reds. Fourth time we pick this one, it says 2 more greens. So the minimum is 6 here. So what is the general approach? When we encounter 0, just increment 1 to the result. And for any other unique value, let's say the value is k1, it can be 1, 2, 3, 4, any value. And its count is, let's say, 7. Or let's say we have 3, answer is 3, and 3 is repeated uh, 8 times. Then we know that once a rabbit, so that means 3, 3, 3, 3, 3, 3. So this says that I and 3 more. So 4, up to 4 threes you can merge. Then next 4 threes you can merge. So 4 plus 4, 8. So how is it done? So this is key and this is value. Value is the count, how many times that key has occurred. So what we will do, divide value by key plus 1. Plus 1 because the rabbit which answered is not counting its own color. And we take the ceiling, just like this example. So here count of 2 is 4. So we know that 3 twos we can merge. And then again, if it takes up to next 3 twos, we will have 3 only. Whether it's 1, 2 or 2, 2 or 3, 2, it will remain 3. So 4 divided by 2 plus 1 and ceiling. So it's 1.33. So 2. So we have to repeat this 2 times and then so multiplied by again key plus 1, that is 2 plus 1. So 6. So the general formula is value divided by key plus 1, ceiling of that multiplied by key plus 1. And this is for each unique value. keep adding to the result. So the time complexity, we are just scanning this list and then again scanning the unordered hash map. So O of n space O of n, because we are storing in a hash map. So now let's write the code for this. So let's have unordered map int, let's call it counts, and then result is 0, and then for num in answers, if num is 0, then we just increment the result. We don't need to store it, we have already accounted for it because this is a unique rabbit. Else we store, increment the count of this value in the counts. And now then we will see all the key value pairs. So result, we add to the result ceiling of count of a key. So second is key, yes, second is count, and we divide by its key, which is the color of, which is the count of, which is the answer that the rabbit gave, and plus one. And but these are integers, so it will always be floor, not ceiling. It will ignore the decimals. So let's convert to double or float, and then we need to multiply with key also. This is what we saw. So this ceiling, one more bracket, and then we can return result. And the solution is accepted. So I hope you understood this problem. So see you in the next problem.